welcome back to the shop, and today we're going to be starting our collet chuck build. Now I'm going to make it a habit to actually put my email address in the bottom of every video at the beginning, right here, and also in the comments. If you guys have anything that you need to get in touch with me directly, do me a favor and use that email address. The YouTube messaging system is kind of wonky for me. Sometimes I get notifications of it, sometimes I don't, and it's actually really hard to reply to those on your phone, which is kind of where I usually reply from a lot of my comments. So if for any reason you need to get in touch with me, ask a question or whatever, email address is the way to go besides the comments on the videos. So like I said, we're getting to our collet chuck build here, and the material that we're going to be using is this hunk of 2 3/4 1144 stress proof. Now I got this cheap. And I did get it off eBay because it was way cheaper. I think it's only cost me like, I don't know, 10 or 11 bucks or something like that. If I were to say order this through metal supermarkets or something of the like, it probably cost me somewhere around 30 bucks. So we're trusting that this actually is stress proof, and I have no way of telling if it actually truly is, but we're going to pretend like it is. And as far as material goes, you just want something that's relatively wear resistant. It depends on how much you're going to use the collet chuck. Obviously the best thing to do would be able to use a hardenable stock, machine it, and then be able to go back and grind it once it's hardened. I don't have the capabilities of that. Probably most of the people out there don't have the capabilities to do that. Your second option, if you want a hardened stock, is to get was it 4130 pre-hard. That's between 28 and 33 Rockwell. It still is machinable and is relatively hard. Stress proof is pretty good. You can even use 1018 or 1045. I mean, unless you're using this thing day in, day out for thousands of parts, I don't see wear being that much of an issue. But you do want something that's not going to mushroom or anything like that. So this here should be more than adequate enough, and we could probably make probably 2 chucks out of this actually. So this is 2 3/4 stock because that's what they had. You can go probably down to maybe 2 1/4. I wouldn't go anything smaller than that, and anything really bigger than this might be a little bit overkill. You can still use it, or you know, cut it down on the outside. Now we're going to be making it out of a solid block here and threading this to fit our spindle. You can use a back plate if you have one and bolt it up to that. It's also a possibility. It's just easier for me to machine everything right out of one chunk. So we're going to need a few things here, and why don't we come over to the bench and kind of explain just a little overview of what a collet is and why they're good, and go from there. Okay, so let's just talk about collets for 1 second here. So anybody that knows about collets, you can move along in the video. The advantage to using collets there are a couple of advantages. The biggest advantage is that they're repeatable. So they're within, usually, I mean, if everything is machined properly, usually within 1 to 2 thousandths or so, or tighter, and that tolerance of run out is repeatable. So you can put something in here, tighten it down, machine it, take it out, do another operation, put it back in and turn again, or have, you know, if you're doing production runs, just have the rod straight through the back and keep, you know, if say you have to make knurled thumb screws, you can turn, thread, knurl part, slide the stock out, thread, turn, thread, knurl, part, and slide the stock out, and so on and so forth. So they're good for production runs and everything else like that. And also they're good because they don't destroy features on your parts. So if you have a knurl that for some reason you have to grab, or threads that you have to grab, a collet exerts a lot more surface pressure around the whole piece of stock, unlike a chuck which just has those 3 points. This will spread the force out and not destroy those features, and it's also good for holding tubing. It won't crush it. Now, Southbend had, Southbends, at least the 9-inch ones, are meant to take 3C collets. And the way they did that is they had a hardened sleeve adapter, which adapted our number 3 Morse taper to a 3C taper. And 3C collets here look just like 5Cs, just tinier. And they have a slot back here which engages a hardened pin in the back of this adapter. So that would hold into there. And then you'd have a drawbar, and the drawbar would thread onto your collet, and this would ride up against the outside of your spindle, and as it tightened down, it would draw the collet in to the taper, compressing it down and holding your part. Now, there are a couple problems with 3C collets. Well, 3 problems with 3C collets. Number 1, they only go up to 1/2 inch, and we do have a 3/4 inch spindle through hole, so we're not being able to take advantage of our entire lathe through hole. Also, 3C collets are relatively expensive, okay? They're not common. You can find them on eBay and everything like that, and sometimes you get good deals on it. The set that I have, I got a really good deal on it. I bought one set from 1/8 to 1/2 by 1/8 by 16ths, I think. Sorry, by 16ths. That didn't cost me that much. I just lucked out on it on eBay. And also somebody had given me, one of my viewers had given me a bunch of them. Now, you're not going to be able to go to someplace like Enco and buy these. You would have to buy them, you know, through the used market. The other issue with any kind of collet like this, like whether it be a 3C or even a 5C, is clamping range. All right, these can only go plus or minus 10 thousandths of their actual stated size. So this is a 1/2 inch one. Your clamping range of this is only going to be on the stock is only going to be about 490 thousandths to 510 thousandths. Okay, so you're going to need a lot of these, and they're going to end up, they go by 64. So you're going to need 32 of these just to cover the range of a 3C collet, and that price can add up. Now, you can also buy 5C collet chucks for the lathe, but like I said, they have the same drawback of the clamping range. So I didn't want to do that, so I went with ER40 collets. Now, ER40 collets, they're usually marked in metric. These happen to be Shar's brand, and these are marked imperial. They're marked 5/16, 1 inch. And I have a range of 5/16 to 1 inch by 1/8, I believe. Right? Are they by 1/8? Yeah. So the benefit to these is obviously over the 3C they go up to 1 inch, okay, and they also have a higher clamping range. So the clamping range of these is going to be about 1 millimeter, which it will give you is about 40 thousandths. So you need less of these to cover that entire range. The other good thing about these is, unlike the 3Cs where the drawbar, the threaded portion is in the back, the drawbar draws it up into the tapered adapter, ER collet chucks thread in from the front. So you're going to have a nut in the front of the collet chuck, and this will be engaged into the taper like so. You tighten down this nut, and it'll actually push the collet into its taper, thereby closing it. Now, this is a commercially bought nut. You can make these. We're not going to. These are only 12 bucks, so it's a lot cheaper to buy it. The only thing we have to contend with is there is our metric threads in here, which we will contend with later. We can get around that. And the other thing is too, is there's a little eccentric in here, and what that's for is to grab this little slot so it engages into that there, okay? So when we tighten this down onto our chuck, when we want to loosen it, we'll loosen it, and it'll actually pull our collet out and disengage it, so we don't have to use a knockout bar to, you know, knock this out of its taper. It self-adjusts, and you know, all the slots in are milled on it for the spanner wrench. Okay, so the other thing we're going to need too, which is going to help you out, is you're going to need some sort of spindle gauge. Now, this is the thread from my lathe here, and I just matched the register size, which is this unthreaded section here. I matched the thread diameter and the thread pitch, okay? And each lathe is going to be different, and also your main body of your chuck is going to be different depending on what kind of lathe you have. Like on this is 1.5" by 8 thread. So, like I said, you can get away with maybe the smallest I would go in diameter of stock is 2 1/4. If you have a smaller lathes like 1 3/8 or 1 7, I think some are 1 7/8 also. You can go with get away with smaller stock. And also, if you have a larger lathe like 2 1/4 thread is kind of common, you'll need a larger piece. But this will allow us to check our internal thread, use it as a gauge as we go. And so what we're going to do is just going to go and say cut about a 3-inch chunk of this off of here, and then we'll set up on the lathe to be able to face this. We need a through hole through this that is slightly larger than 1 inch, so we can pass a stock all the way through it. Even though we only have a 3/4 inch through hole, I still want to get that 1 inch stock all the way through as far as I can. So I need a 1 inch hole all the way through, and then one end of this is going to be opened up to the minor diameter of our 1.5" thread. So let me cut a piece of this off on the bandsaw, and then we can go over on the lathe and start working on that. Okay, so we're in place here. So I'm going to do the centering trick here. I'm going to find a low spot, which ends up being right there. Find the high, 62. So we're going to half that reading, so we're going to come back to 31. I'm going to set 0 there. We're going to go to our next closest jaw here. I'm going to work our 2 opposite jaws here, and we're going to bring that reading to 0. Go to the next set, and I'm going to work our jaws there again. I'm going to bring that reading back to 0. So just by doing that, we're now within 5. So now we can just work our highs and lows against each other. So there's our low, so this jaw's high, give it a little tweak. Now we're within 2. Find our low spot is between those 2 jaws, so we'll tweak this one in a little bit. And we'll give this one a little tweak. Could be a dip in this bar there too. You can see we're getting closer every time. So we're within 1. There's a little bit of a dip right there. Alright, that's close enough for what we need to do. So we're going to be turning this outside diameter again anyway. So what I want to do now is face this off. Now you can see this is all scaly and rusty here, so I'll put something on the ways and just until we clean up that cut. That'll block all that schmutz from going everywhere. Okay, let me grab a towel. See if this will actually stay in place. My luck, probably won't. Alright. pretty damn good finish there. The Okies up my tool there. Alright, so basically right now what we want to do is slap a 1 inch hole through this, so slightly larger than 1 inch. Doesn't have to be it doesn't have to be bored exactly to 1 inch or exactly to a size, just slightly larger than 1 inch as a clearance hole for our largest collet, which will be a 1 inch collet. And then we'll start to open up this side for 1.5 inch thread. So let me get my drill bits lined up and then we can just plug right through that. Alright, so we got a decent sized hole in here. We're at pretty much 1 inch right now. And you know, because I was using some good old, you know, cheese grade drill bits that don't like to hold an edge. This is a little bit out of round and not quite the size. You know, a decent set of drill bits is on the wish list, but you know, I'm gonna make do with what I got for now. So we're just gonna bore this out, and we want a nice clearance hole for a 1 inch diameter rod. So we'll bore this out to 1 inch 100 thousandths. That gives us a nice bit of clearance in here to make sure that when we clamp the collet, that the only thing touching the only thing that the bar is touching is the inside of the collet and not the inside of this collet chuck, which could skew it off. So basically we're just gonna bore this out and you know, make it nice and round. So just get a little bit of Earl in here, and I'm just using a hand ground high-speed bit with a little bit of a radius on it. So the finish in there might not be perfect, but or the best it can be, but we're just looking for a diameter. It doesn't, finish-wise, doesn't really matter much. So we're going to take about 20 thousandths. We're feeding about 5,000 per revolution here. Yeah, we got a halfway decent finish in there. It's not too bad at all. So I'm going to finish boring that out. I'm going to go to 1 inch, 100 thousandths for clearance, and right now we're at 1 inch, 30 thousandths. So we got a little bit to go. So let me just finish boring that out, and then we'll come back. Okay, so now we have Our bore opened up. I got a smaller boring bar in here. And we got to open up this to our minor diameter of our 1.5 by 8 thread, which for me is 1.365 or 60. I'll double check. But we're going to open it up to that diameter. And I have a carriage stop set here. This is an indicator mounted to my carriage. I have that set for my depth, and I'm going by my spindle, and I want a depth of about 1 inch, and that gives me enough room to be able to come back in here with a grooving tool and put a relief groove on the inside for our threading. It also gives me enough clearance so we're not bottoming out on the front of our spindle, but this will be able to tighten down, and this face will bottom out on the actual rear flange of our spindle. We want to make sure that we don't bottom out on the threads. We want to hold this face against that little flange that's larger than the threads, and then we'll come back in here after we thread it, and we'll just nick the threads down to our actual little register on the end, which for me is I have it written down here. What did I write down? 1 inch 511 thousandths. The actual Southbend book states 1 inch 509 thousandths, but by my mic it's 511. So we'll turn it down to probably 512 or so, 512 and a half. Give us just a little bit of clearance on that register, but we want a nice snug fit. So I'm going to go ahead and we're going to start boring this out here. Just going to slow down the lathe a little bit. And I'm just gonna go, probably go about 50 thousandths at a time. See how that works. And I'm feeding in about 5 thousandths per revolution. we go. And a nice chamfer on the inside there. And that's it. So clean that up and I'll re-mic it. Okay, so I'm going to re-mic this. And we're going to mic over it here, and we got and what we really want is 1 inch 364, 1 inch 364 and a half, and we're one 364 and let me hit it again. 1 364 and I'll call that 6. 1 364.6, and we want 1 364.7 it to be exact. And so we're good to go to start threading this. What I want to do before I start threading that is I need to come into this face here, and I need to make a groove. Now we want the groove deeper than the actual thread depth, and that's going to be our relief groove for our threading tool. That's where it's going to end up. So I actually have a grooving tool that I made for one of my other projects, and this happens to be just a piece of cold rolled steel with a piece of high-speed steel silver soldered to it, and it's cut in as a grooving tool. And this is what I use to make O-ring grooves in the downfeed mod on the saw there, and I have just enough stick out to be able to get in there. So I actually don't need to move the tool, but I do need to make sure that this tool post here is nice and straight with the face. And I can basically come in here, and we want to go, what's the double depth of 8 thread? It's 160 something. 8 threads per inch. 100 and double depth of thread is 162. So we'll go a little bit deeper than that to make sure we have plenty of room to clear our threading tool. So I'm going to lock that carriage down. I'm going to come in. That's just skimming that face. Alright, there's our actual hit. I'm going to set 0. And I'm actually going to slow this lathe down because it does not particularly like internal grooving. Let's see if that's slow enough. Yep, that is not slow enough. Alright, let's slip the guy into back gear here. Okay, you can see that internal relief groove in there, and that's what is going to allow me to land my threading tool in there